Good evening, everyone. Welcome to the course Environmental Chemistry. So this is week 9 of the problem solving session. So as you know, that we will solve some basic assignment problems as well as the problem that will be helpful in the examination if you have registered for it. So this is week 9. My name is Mansi Tripathi. I am TA for the course and I'll help you in solving these assignment questions as well as if in case if you have any doubt. Okay, so we'll start with question number 1. Then we'll start solving one by one. Almost 10 questions will be there. So the first question is, what is a controlling solid? So this is a question based on understanding. Today, for information, most of the questions will be mostly based on understanding. One or two questions will be based on the visual Mintek. So the first question is saying, what is controlling solid? So solid driving concentration of metals in solution, or the controlling solids are the solids having no chance of being formed in any condition, a solid with maximum dg amongst others. Okay, so what from all these equations options are the controlling solids? So we'll see the solution now. So the option is solid driving concentration of metals in the solution. Okay, the controlling solid is a solid that drives the concentration of the metals or the ligand that is present in your solution. So this is what we call controlling solids. Coming to question number 2. Question number 2 is ferric chloride or iron third chloride, that is FeCl3, is used as flocculant and sewage treatment and drinking water production. So when there are many colloidal particles in the water, then we use ferric chloride. Mostly it is used in sewage treatment. Okay, and for this purpose we use alum in drinking water production. So it is mostly used in sewage treatment. So we use some ferric chloride. So what it will do, it will start forming flocks, and it will, in that process, it will take, by different mechanism, it will start taking different colloidal particles with it, and it will start settle down. So this is the process of flocculation. Now, I hope that you are already aware of this process. Then when small quantities of ferric chloride are added to the raw water, iron hydroxide precipitates and adsorbs finely divided solids and colloids. So this is exactly what I explained. If it is assumed that iron hydroxide precipitate is formed in a lab experiment, deduce the composition of iron total as demonstrated in the lectures. So why we have mentioned lab experiment explicitly here? Because in real scenario there will be multiple, not only ferric hydroxide but different types of hydroxides that will be formed in these lectures, in these experiments. So that's why a lab experiment is explicitly mentioned here, so that you can know only ferric hydroxide will be formed other than simple like iron, suspended iron ions. So among these options, what can be those? Please take some time and try to deduce it. This can be easily done in your visual Mintek also. Okay. So while doing that, this will be your solution. The total iron will be in the following forms. If it will be definitely in the form of metal ions. Okay, because it is in solution form, so definitely metal ions will be there. Second, it may form metal complexes. Okay. Third, it may form some metal solids or metal precipitates. So because it works in a certain pH level, so if the pH is like we say, if the pH is desirable for the formation of metal solids or precipitates, then some metal solids may also be formed. Otherwise, it won't form. There will be metal complexes definitely and metal ions. So we are using this book, Water Chemistry and Introduction. So from the knowledge of hydroxide complexes, from table 9.4, stability constant for the selection of metal ligand complexes, from this particular book, So this we have mentioned because we should know what complexes will be formed. So from this book we have taken these complexes. Okay, so it's better to mention source so that you can also understand what complexes will be formed. It's difficult to remember all the complexes, right? So that's why we always use appendix of any book. So we try to mention all those things. So, so there are chances of, because in the question it's written, there will be formation of precipitates because third line, as you can see, I'll highlight it. Here we say hydroxide is precipitating. So of course there is the formation of solids. So all these things we have mentioned. So just total iron will be all the complexes plus solids plus metal ion. So this is very simple question. You can directly get this solution in Visual Fintech. Apart from these complexes, you will get many other complexes in Visual Fintech. So question number 3 is select the appropriate measure for promoting precipitation in a, we are trying to promote the precipitation. Okay, we are trying to increase the insolubility of a compound. So here multiple options will be correct. Increasing the saturation ratio, adding a ligand or complexing agent, or we can decrease the saturation ratio or by increasing solid concentration. So which of the following are used to increase uh, the precipitation? Okay. We'll see the solutions now. So the solution is we can increase either the saturation ratio or we can increase the solid concentration. Like for increasing the solid concentration, a very simple example. If you mix NaCl in water, if you keep on adding NaCl, there will be a time that it won't dissolve. Okay, so by increasing the solid concentration, we can promote precipitation, right? And the second is by increasing the saturation ratio. So this is a solution. So factors promoting precipitation are saturation ratio and solid concentration. But on the contrary, if we are adding a ligand, so what will happen if we just add a ligand or complexing agent? It will trap the metal ion and it may make it to remain in the suspension. So it will prevent it from forming precipitation. Okay, so these complex reactions or the complexation formation prevent the ion from forming a precipitate. Next option is decreasing saturation ratio will produce opposite effect of increasing saturation ratio. If the increasing saturation ratio is promoting precipitation, decreasing will reduce the precipitate formation. Question number 4 is in the sample of groundwater extracted from a well, the concentration of calcium IS is so expected to lead to formation of following solid. So, like this question is saying that we sampled a well, we found the calcium ion solution concentration, and it is expected that it will lead to the formation of these four types of solids. Okay, so one is calcium carbonate. All these types are in solid form, but with different anions. One is carbonate, second is portlandite, that is calcium hydroxide, third is gypsum, means calcium sulfate, and D is hydroxyapatite. So this is a phosphate salt, a phosphate and like this is a phosphate salt. Some are carbonate, sulfate, hydroxide. Okay, and we have seen the KSP values of all these things also. So what will be the order of formation of above solids? So based on the KSP values, we can find out the order of formation. So what is KSP? Like, just let's talk about CaCO3. CO3. When it will dissociate, it will lead to the formation of Ca2 plus CO3. So what is KSP? Activity. Let's consider it as an ideal solution, then concentration will be equal to activity. So I am writing directly concentration here. Ca plus, multiplied by the concentration of carbonate. Okay, so this, according to this thing, will be 10 raised to power minus 8.48. So looking at this thing, it can be considered that most of the form will be in the form of the reactant, means CaCO3. Okay, because the solubility coefficient is very less. If solubility coefficient is high, it means mostly it will be in the form of anions or ions in the water. But since it is very less, it will be mostly in the solid form. Okay, so these are the KSP values given. So based on that, we need to identify which will be formed first and which will be formed later in terms of precipitates. So looking at the answer is CBAD, means this compound is having lowest KSP will be formed first. Okay, so solution with higher log KSP will be formed first, hence CBAD, and this is the sequence. First gypsum will be formed, then portlandite, calcite, then hydroxyapatite. This is the sequence of the formation of the compounds. So this gypsum having low log KSP, the highest, means if we consider minus also, so this is the highest. So when we will write it in the terms of KSP, then it will be 4.61, 10 raised to power minus 4.61. So it will be formed first. Question number 5 is, a solution contains 0.001 molar of Ki, means potassium iodide, and 0.1 moles of KCl per liter. So it's a molar solution, 0.1 KCl potassium chloride per liter. AgNO3 is gradually added to this solution and observed. After some time, a precipitate was observed in the solution. It was concluded that it could be either silver bromide or silver iodide. We have to consider the following reaction having different KSP values. This should be written here. These are the different KSP values. So consider the following statement regarding formation of precipitate. Which will be formed first? This question is very similar to question number 4, and it can be easily answered that which will be formed first, AgCl or AgI. Okay, based on the KSP values, it can be considered. We need to find out the log KSP. Then we can say that the precipitate having higher log KSP, that will be formed first. So the answer is AgI forms first. So solids with higher log KSP will be formed first. Question number 6 is, for an experiment, a silver bromide solution was made by dissolving AgBr in water. The following equilibrium is observed in the above mixing. So we have Gibbs free energy in kilojoule per mole for the concerned component. We have Ag plus Gibbs free energy of everything. Ag plus AgBr, Br. This will be 10 raised to power 4. Sorry. No, we'll see. Using the data and standard temperature 25 degree, not 10 raised to power 4. Okay. The solubility product of the solid we need to calculate. So this question is numerical type of question. You have to enter the values in a particular range. No options will be given for such question. You have to calculate it manually and enter the solution in a given box. And if it is lying between a particular range that we are thinking of the correct range, then only marks will be awarded. So be very careful in what terms it is asking the question. So if it has asked in KSP, okay, but the question is in form of log KSP. So be very mindful while solving such questions. Let's see the solution. So delta G is minus RT ln K. So what is delta G? It should be product Gibbs free energy of formation of products minus Gibbs free energy of formation of reactants. So this is delta G, product minus reactants. So you can see this was the product and these are the reactants. So Gibbs free energy of formation of products minus Gibbs free energy of formation of reactants. So very easily we can find out ln Ks naught by dividing it by RT, and ln Ks naught we will get will be this. So this is your KSP values. Next question is, consider the following statement regarding the formation of precipitates in a supersaturated solution. Rate of nucleation and crystal growth are heavily dependent on saturation ratio. We have to consider these statements and we need to find out which statements are correct. Rate of nucleation depends upon saturation ratio. Rates of nucleation and crystal growth are heavily dependent on surface area density, or it depends upon surface area ratio. Which of the following statements are true? Please take a minute or two and solve this question so that we can see the solution. We'll see the solution now. So the solution is B and D. Here 1 to 3 is written, but consider it as A, B, C, D. Okay, so B and D are the correct thing. Okay, so this is all the statements. Before going to question number 8, we'll see once again from the beginning so that you can note down all the questions who has joined now. So the first question is, what is controlling solids? So here we need to find out the solid, like there will be formation of different types of solids in a reaction, right? So which type of solid, like if the cation is calcium and anion can be hydroxide as well as carbonate. So which will be formed? So which is controlling solids? So the solution deriving concentration of metal in solution, or for which there is no chance of being formed, a solid with maximum Dg amongst others. So the solution is solution deriving concentration of metal in solutions. Next question is, ferric chloride is used as flocculant. So why we are using this ferric chlorides? This will form a gelatinous ferric hydroxide which precipitates, and in the same process it will collect, like it attracts, or because of the gelatinous structure, it will attract small finely divided colloidal solids, and in the process of settling, these solids will also settle with sodium hydroxide. So the question is, we need to find out the total solids. So what will be the total solids here? So one thing for sure, there will be metal ions in the solution. Second, hydroxide is forming. And third, because it is precipitating, so sodium hydroxide like FeOH3 will definitely be there. So two things are must. The question is saying FeOH3 should be there, so that will be there, and Fe3 plus in the cationic form, it will also be there in the aqueous solution. Other things we need to find out. So adding all these things, we will get the equation of Fe total. So how we are doing it? So as I've told, metal ion will be there, complexes will be there, and metal solids will be there, because the question is saying. So from using this book, Water Chemistry and Introduction, we found that these four type of complexes are possible. You can refer to this book, table 9.4 of this book, and we can find out different complexes. So just by adding all these things, Fe3 plus, FeOH and other things, we can get the total solids. If we will solve this question as visual Mintek, there may be the possibility of formation of more products depending upon the given pH and the molar concentration. So when you will find out the species distribution, you can find out that there will be more complexes. But this question was simple. This was just asking about the hydroxide complexes, so this book can be used. Question number 3 is, select the appropriate measure for promoting precipitation. We want to promote precipitation in a solution. Okay, so take your time and you can solve this question. Then we will move forward to next question. Okay, we'll see the solution now. So by increasing the saturation ratio and the solid concentration, we can promote the precipitation. I have given this example earlier also. Like if in a bottle you are if in a glass of water you are mixing salt, if you keep on increasing the concentration of salt, then a time will come that no more salt will dissolve. The dissolution will be in dynamic equilibrium. So by increasing the solid concentration, we can promote the precipitation, right? That is one of the good example. These are the solutions. Coming to question number 4. Then in a groundwater extracted from a well of concentration of calcium ion. So, we are expecting that these 4 types of solids or precipitates will be formed. We have given the KSP also. So the question is, what will be the order of formation of above solids? So this is our question. So well, like calcium carbonate will dissociate into calcium ion and carbonate ion. KSP will be Ca2 plus, concentration of Ca2 plus multiplied by calcium carbonate. So please look at the question following, look at the following options and let me know what will be the sequence of formation of the above solid, which will be formed first and which will be formed last. We'll see the solution now. So the solution is gypsum will be formed first because it has highest log Ksp values. So we are not looking at the absolute values. We are looking at the value as a whole. So minus 4.6 is higher than other values, right? So that's why looking at log Ksp values, gypsum will be formed first and the other thing will follow in the sequence of log Ksp. Next question is, a solution contains 0.001 molar potassium iodide and 0.1 molar potassium chloride. AgNO3 is added to this solution and observed. So this is the titrometric experiment. So after some time a precipitate will be formed in the solution. So it can either be silver bromide or silver iodide. So this is the equation given. So consider the following statement regarding formation of precipitate. So it's kind of question number 4 only. So please try to solve this question and we'll see the solution in a while. Here also we need to calculate the log Ksp and like as we did in previous question we can find out which will form first. We'll see the solution now. So answer is AgI because it is having uh, higher log Ksp values. So log Ksp will be higher, right? So it will be formed first. Next question is, for the given experiment, silver bromide solution was made by dissolving AgBr in water. The following equilibrium is observed. Okay, so Gibbs free energy is given for all the components. We need to find out the log Ksp values. I hope you remember the solution from first lecture. What is Gibbs free energy? By using that we can find out this question. And this is numerical based solution. So be very careful what the question is asking. Take some time and solve this question. We'll see the solution in a while. We'll see the solution now. So delta G is equal to minus RT ln K. So here K is KSP. So delta G is equal to Gibbs free energy of formation of product minus Gibbs free energy formation of reactants. So we are talking about the precipitation reaction, right? So that's why precipitate will be the product. So this is the 96.9 minus 77.12 plus 104. This is what we got, 123780. Then ln K naught is equal to Gibbs free energy, change in Gibbs free energy divided by RT. So R is 8.314 and T will be in Kelvin, degree Kelvin, right? So 298.15. So when nothing is given, we will take these values 298.15. Okay. So ln K naught, this is what we got, minus 49.93. Question number 7 is, consider the following statement regarding the formation of precipitates in a supersaturated solution. What is supersaturated solution? It has gone beyond its dissolution capacity. So what will be the correct option? I have already marked here the option 2 and option 4, means option B and D. This is the correct answer and this is the solution for the same. Now coming to question number 8. Massive industrialization and urbanization of civilization during the last few decades have made a thrust in heavy metal production in various water bodies. It is a fact. A similar industry was selected for analysis of harmful concentration and sampling was done from a plant's effluent and following observations were made. We found when this factory effluent was observed, what was that we found? That total chlorine concentration was 10 raised to power minus 2 molar. Total zinc was 3 into 10 raised to power minus 5 molar. And total carbonate is 5 into 10 raised to power minus 3 molar. And pH is 8. So this is slightly alkaline water. It is assumed that possible solid formation is ZnCO3. So determine the dissolved Zn concentration in the sample taken. Okay, we have to solve this question by using Visual Mintek. So please take some time and try to solve this question. We'll see the solution in a while. So the correct option is option number A, 2.34 into 10 raised to power minus 6. And how this is coming? So first of all, we'll fix the pH to 8. So here at the very first option, we'll fix the pH to 8. Then we will add the components. We will add one component one by one and their total concentration. And we can do that by clicking or view edit list. So this is what we got. So we will specify infinite solid species from the top menu bar. So this window will open. Then we need to find out the name of the solids. Like in question it is given, it is ZnCO3, right? So we will put ZnCO3 here. We have to ensure that we have clicked the check boxes so to avoid confusion with solids that may not be formed. So after putting this thing, we have to tick this check box so that it won't show other solids that can be formed. We are talking about just ZnCO3. So then we will run Visual Mintech and we will view the result. This is the equilibrated mass distribution, and we can see that Zn is forming is 2.34 into 10 raised to power minus 6, and as it was mentioned that stoichiometry of this solid is 1:1. So the amount of Zn2 plus will be equal to amount of CO carbonate ion that will be involved with Zn. So ZnCO3 will be equal to amount of Zn2 plus. So this is 2.34 into 10 raised to power minus 6 is the solution. Now next questions are connected questions, question number 9 and question 10. So the following data will be relevant for both the questions. A township is being planned near an industrial area. In the planning and development process, viable alternatives of drinking water were being looked into. A surface water being evaluated as a possible drinking water supply source, and preliminary testing result shows the following data. The pH was 7 and total calcium concentration is 185 milligrams per liter. Please note down this thing so that we can move forward to the question. We'll see the question now. Question number 9 is determine the alkalinity of the solution in terms of calcium carbonate. So we have pH and we have total calcium concentration, right? So there will be alkalinity. So we need to find out alkalinity if it is an open system, means it is in equilibrium with the environment. So we will take atmospheric carbon dioxide and the pressure is 0.00038 atm for Visual Mintech. We will solve this question in Visual Mintech. So please try to solve this question. We'll see the solution now. So the answer is 10.55 milligram per liter as calcium carbonate. This is the alkalinity in an open system. So we have pH, we have total calcium concentration, we have CO2 pressure. So feeding all these values in visual Mintek, we will get the alkalinity as CaCO3. How? So first we will fix the pH to 7.5. Then calcium ion we are adding as 185 milligram per liter, and we have to be very sure that we are selecting the concentration unit as milligrams per liter. Then we will fix the gases. So partial pressure is added 0.00038 atm as given in the question. Then we will just run visual Mintek, and this is all we will get. Bicarbonate concentration, carbonate concentration, H plus OH. So what is alkalinity? Alkalinity, as we have studied in earlier lectures, that will be bicarbonate plus 2 times carbonate plus OH and minus H plus. So putting these values, we will get CaCO3 as 10.105 milligrams per liter. Okay, so this is the equation: bicarbonate plus 2 times carbonate OH minus H plus ions. Coming to last question, fill in the blanks. With respect to calcite solution is question mark. So this is the question, it's a connected question, right? So the how to do this question is also given here. Use view saturation index option in output menu of Visual Mintek. So with respect to calcite, here a comma should be there to make the question clear. The solution which is forming after, which is in equilibrium with the atmosphere, it is undersaturated, over or supersaturated, or it cannot be determined. So please have a look at this and let me know how this will be solved. You can take a minute or two for solving this question. We'll see the solution now. So the solution is undersaturated. How? Just by going to saturation index and the result page, we will get all these things. So as we can see, saturation with respect to calcite, calcite is minus 0.6 and agronite is minus 0.7. So we can see that this is the only thing, like we have to do this question with respect to calcite only, right? So other things are greater than 1 and this is less than 1. Of course it is in minus terms, but it is less than 1. So we can say that with respect to calcite, solution is undersaturated, and with respect to other things, because it is greater than 1, it is oversaturated. With respect to aragonite also, it is undersaturated. Okay, but the question is The question is asking with respect to calcite only, right? If the question is with respect to veterinite, then it is oversaturated. But here it is undersaturated. Okay, so that's all for today. We'll close the session.